Welcome dear student, how are you all? I hope you all are fine. So today we shall begin a new lesson, that is current electricity. And this lesson is for class 9 science, and this is part 1 video of this lesson. So let's start part 1 of this lesson. Okay, so student, electricity. So electricity is of utmost importance in the modern world, and we depend on it. That is, we are depending on the electricity for almost everything in our day-to-day life. So in order to avoid the inconvenience faced due to failure of power supply, hospitals, banks, offices and private institutions make alternative arrangement with the help of a generator. So this is a generator machine which converts mechanical energy, that is mechanical energy of machines, into electrical energy. So student, electricity plays very important role in our daily life, as you all can observe the white chart in which I have mentioned in which area the electricity is using. So almost in all bases, in all way, we are using the electricity. Okay, so student, electricity is used for running electric furnaces, electric motors and several other instruments used in industry. So everywhere there is importance, lots of importance of electricity. So in case of a power supply, when power supply is off, so we are suffering lots of problem. All right, so it is basic, or we can say very important thing of our life. All right, now student, domestic appliances, that is household appliances like the fridge, refrigerator, electric oven, mixers, fans, washing machines, vacuum cleaner, roti maker, almost everything have helped us by saving time and labor, and all these devices cannot be run without electricity. Okay, so it plays very important role again in our domestic in our houses. Okay, and not only human beings but some animals also use electricity. So apart from human being, animals also using electricity. So let's see how. Okay, so here a student, you can observe the eel. Okay, so this is an electric eel, that is fishes such as eels use electricity to catch their prey and also for self-defense. So this is an electric eel which using the electricity. Okay, which using the electricity for their self-defense, or just to catch their prey, or just to defense from their enemies. Okay, and the lightning. Okay, so lightning, so this is a rainy season is going on, and you all must have observed the lightning, right? So the lightning that strikes the earth is an excellent example of natural flow of electricity. So lightning is a natural way by which the earth will getting the electricity. Okay, all right, so student, you must have seen a waterfall. Okay, so this is very beautiful waterfall. So which way does the water flow in waterfall? So student, water is always flowing from upward direction to the downward direction. Okay, so this is just because of the gravity, or I hope you all know about the gravitational force of the earth. Okay, so just of the gravitational force of gravity, water is flowing downward direction in waterfall. Okay, so this is a downward direction of the water in waterfall. So student, for the generation of electricity, water is released from a dam at a higher level, and because of the gravity it falls to a lower level. So dam, I hope you all know that dam are using for generation of a power, generation of electricity, dam water is used. Okay, and thus, as we know, the direction of flow of water between 2 points depends on the level of 2 point. It is level from higher concentration to the lower concentration. Okay, so this is a structure of a dam in which you can observe here it is a dam. Okay, in which in dam this is a type of a water reservoir. Okay, so from the water reservoir, or here you can observe the head pond. Okay, so the water is taking from the pond or dam, and then this whole construction is made so that water is derived from the point, from one point to the another point. Okay, from the penstock. So penstock are basically the channels from which the water is moving from pond or dam to the turbine system. So this is a generator turbine system where the electricity is produced by using the generator or turbines. So this is a way to produce an electricity by using the dam. Okay, student, our next topic is potential and potential differences. Okay, so let's understand what they are. So first, let's see basic definition of potential and potential difference, that is PD. Okay, so first, potential or electric potential. So what is it? So student, electric potential is the amount of work needed, amount of work or amount of energy needed to move a unit charge from a reference point to a specific point against an electric field. So here you can observe a diagram in which you can see the charges are flowing from the higher potential to the lower potential. Okay, so these are moving from positive to negative or higher potential to the lower potential. So this is an electric potential. It is the amount of work needed to move a unit charge. Charges means like electrons from a reference point to a specific point. That means from positive to negative or from higher potential to from lower potential to a higher potential against an electric field. This is the electric potential. And next is so this is a circuit, electric circuit. You can observe the charges at higher potential, that means from positive to negative. Okay, charges at low potential will move toward the charges at high potential. Then only the light, the bulb will able to glow. Now next is potential difference. So potential difference is a difference in the amount of energy that charge carriers have between 2 points in a circuit. So these are the potential difference is a amount is a difference between the how the charges are flowing from one point to the another point. So this is a potential difference. So I hope you all have understood electric potential and potential difference. Let's move further. Okay, so here one activity is given in our textbook in which this is a diagram of level of water and direction of a flow. So here equipment needed are we required plastic bottles, 2 plastic bottles, okay, and rubber tube, clamp and water clamp just to tie the tube, okay, just to block the tube. And we need water and set up the experiment as I shown in the diagram. So then what happened, student, set up the experiment. First of all, we have to set up the experiment and then remove the clamp from the rubber tube. Okay, so this is a diagram and remove the clamp from the rubber tube, and we have to observe some points. That is, first question is what happens when the clamp is removed. So I hope you all can observe the clamp in the white diagram. Okay, so what happened when the clamp is removed? So student, when clamp is removed, water will flow of a water will start from higher level to the lower level. Okay, so water will move always flowing from higher concentration to the lower concentration. And does the water stop flowing? Yes, water will stop flowing when it will attain the equilibrium or balance position. Okay, so student, just like water, the flow of an electric charge between 2 points depend on a kind of electric level at those points. That means in previous slide we have seen the water will start flowing after removing the clamp. What happened? Water will start flowing from a level of a higher concentration to the lower concentration. So that like that only the electric charges will flow from level of a higher concentration to the lower concentration. Okay, and this level is called as an electric potential. So whenever the charges means a flow of an electron from a higher concentration to lower concentration is nothing but the electric potential. I hope you all have cleared about electric potential. Okay, now next is a positive charge. Positive charge flows from a point of higher potential to a point of a lower potential. Now student, lower potential is a point having lesser concentration of a charges, and higher potential is a point where the high amount of a charges will be there. So like water only, the charges will flow from higher potential or higher level to lower level where the number of or where the amount of charges are low. So it will move from higher to lower concentration. Okay, so it will always move higher concentration to lower concentration. Okay, now electricity flows due to the conduction of negatively charged electrons. Okay, so flowing of a charges means what? Flowing of a electrons. Okay, so electricity flows due to the conduction of a negatively charged electron, and electrons flow from the point of a lower potential to a point of a higher potential. Okay, so student, don't get confused. Electrons will flow from the point of a lower potential to a point of a higher potential. And a lightning strike is a flow of electrons. So here in this diagram you can clearly observe the electrons will flow from negative to positive. That means lower to higher potential. Okay, lower to higher potential, lower to higher. And a lightning strike is a flow of electrons from the point of a lower, that is negative to potential on the clouds, to the point of a higher potential. So this is opposite, that is lightning strike is a flow of electron from negative to zero, that is lower potential to higher concentration, higher potential. This is same thing. Okay, alright, now potential difference and flow of electricity. Here diagram is given just to observe the potential difference and flow of electricity. Alright, so student, in this the difference between the values of a potential at two different points, that is at point A and B, is called the potential difference between them. That means how many charges are flowing from A and B, point A and B. This is a potential difference. Okay, and in this diagram, conductor A is a higher potential. Okay, it is a higher potential than conductor B. So conductor B is a negatively charged conductor, which is a low electric potential. When these two are connected by a conducting wire, a potential difference is created. That means charges will flow from higher potential to a lower potential. So a potential difference is created between its two ends, that is from point A to B, and electrons will flow from B to A through the wire, and this flow will continue until the two conductors A and B have the same potential. Alright, and that is until their potential difference becomes equals to zero, and only then will the flow of electrons will stop. So when the potential difference becomes zero, the flow of electron will stop. And student, work has to be done against the electric field to take a positive charge from a point of a lower potential to a point of a higher potential. So student, I hope you all have understood this video, and next part we will continue in our next session. Thank you all of you.